Alrighty, everyone, welcome back to another episode of the Modern Mobile Oilfield. Now, if you're watching on YouTube, you probably have an idea of what today's topic is, but if you're listening in podcast format, consider subscribing to the channel. Not only is it just as entertaining as those random sports videos or meme compilations, but it's going to help you grow as well. But enough of chilling the channel. I can't keep our guests waiting. Ladies and gentlemen, again, we are joined by the king, the Elvis Presley of oil and gas tech, Geoffrey Cann. Welcome to the show.
Oh, thanks very much. First time I've been compared to Elvis Presley, I have to say.
Hey, hopefully not the last. Like I've said time and time again, the series is wonderful. It's only going to continue to get better. That's no secret. But this series will never replace this here book, the Bible of oil and gas tech, Bits, Bytes, and Barrels. You can pick yourself up a copy for $10, wildly enhance your understanding of the industry in more ways than you would know. But I think we've done enough introductions, so let's jump right into today's topic, artificial intelligence. Now, Geoffrey, with AI, can I expect an iRobot remake with Will Smith in the North Sea on a floating platform?
Eventually.
Eventually. How can you Sorry.
No, it won't be for a long time, unfortunately. But yeah, that's the trend line is very clear as to where this technology is headed.
Soon. Now, how could you succinctly describe AI and its applications? Is it more than just asking Siri to add something to my grocery list? I would hope it's far deeper than that.
Well, the definition of artificial intelligence is a complicated one because it covers such a vast range of related and similar technologies. The simplest explanation for me is one where we take an extension of what we mean by intelligence. In other words, the characteristics that make us humans or beings. In other words, a series of senses that are not at the moment easily amenable to replacement: hearing, visual, sound, taste, sense of smell, and so forth. We have developed lots of sensor technology that can enhance or support those different human senses, but the ability to take in something through your eyes, if you like, if you think of your head as a movie camera and you're taking in through your eyes, the lens, the visuals of what's happening in front of you, the ability to interpret that in an instant, make a decision around what to do, if anything, and then take that action is an inherently human characteristic. Machines can't do that easily. And the same thing with language processing. I'm speaking in English, you're listening to it, and your brain is automatically translating the sounds into words, the words into meaning, the meaning into understanding. All of that happens in an instant. And that kind of intelligence to be able to do things like language processing, visual data interpretation, it falls into this category of technologies called artificial intelligence. If intelligence is the ability to process that data, artificial intelligence is the machine that can replicate or perform much of the same characteristics.
All right, so certainly a very promising technology, but through your research, what advantages and disadvantages have you seen in everyday or even oil and gas applications?
Well, there's so many use cases for this kind of intelligence tool set in oil and gas. It's almost hard to describe where to begin. But as one of my network contacts has explained to me, any job today that involves a human being staring at a dial, staring at a readout, and making a decision whether to turn or not turn a dial, that job is amenable to be replaced by something that is artificially intelligent and doing the same job. So the advantages are enormous. Just visiting well sites where there's a requirement to inspect, look at the gauges, capture the data that's there, and make a decision around whether or not to schedule an asset for maintenance, or to turn down or turn up a producing asset, a pump, for instance, or whether to plan for an inspection for corrosion. All are kind of a decision-making process that requires informed intelligence, and all of those jobs are amenable to the use of this technology. So the advantage is the significant automation of much of this infrastructure, which, as we know, is very susceptible to human error and human omissions and oversights. So the advantages are efficiency, cost improvements, productivity, asset utilization, all improve. The disadvantages are that if you feed these engines incorrect data, they will make an incorrect decision. And so therefore, the kind of data that you feed them is important. They work better the more data you give them. And so these engines require enormous quantities of data. And that data might not be easily amenable to computerization, such as on paper documents and whatnot. And then finally, the biggest disadvantage is more perceptive than anything. But at a time when many organizations and we're all struggling in this current pandemic setting with jobs and job losses and unemployment, using this kind of technology to further remove jobs is alarming for many people. So its disadvantage is more of a change management question and a perception question, in my view. But I guess gives you a bit of the balance of the pros and the cons.
Yeah, it seems pretty equally balanced so far, and perhaps this is beyond the scope of what the current capabilities are, but how can we further improve it to mimic, I guess, human rational decision making? Because like you said, my eyes are seeing, I'm hearing, I'm tasting, I'm touching. Subconsciously, my mind is filtering a ton of that data and information, and then I'm processing that. Is it just a matter of time and better sensors and better chips?
That's exactly right. In my book, I articulate this little illustration of this phenomenon. You know, the reason the Wright brothers aircrafts were able to get off the ground. I mean, humans knew all about how flight worked for centuries before the Wright brothers came along. But how did they get their aircraft off the ground? They had a fuel dense enough that could create enough energy when you burnt it. In this case, fuel, gasoline. You could spin a propeller, and the propeller had enough lift to get the aircraft off the ground. The analogy is exactly the same in the world of cloud computing, big data, and analytics. That we now have enough accumulated data, analytic horsepower distributed by cloud computing that we have, in effect, enough information density. In the same way that the Wright brothers had fuel density, we have information density in place, available and accessible, that we can process at very, very fast speeds, that we now can do things that we couldn't do before, including using artificial intelligence to do stuff like language interpretation and translation and site visualization interpretation. That's why we're at this cusp of the role of artificial intelligence really taking off.
And then AI has been around in sci-fi for a long time and even reality for a little bit. So what are some entertaining, maybe fun uses that have existed or are being developed that people may not know about?
Well, there's lots of examples of it. A fun one that is you can try out on your phone if you want is called Google Quick Draw. So Quick Draw is an application where you just start tracing out with your finger on your phone, and Google will guess what you're drawing. And it's uncanny how fast it is at being able to interpret some as you start drawing. It immediately starts guessing. So if you start drawing a circle, Google Quick Draw will quickly say, well, you're drawing a circle, a tomato, a watermelon. And if you start just adding a little bumps across the top, it'll immediately go, oh, it's a blueberry. And so it's very quick. It's super fast. And so it's I use it in when I do lectures and so forth. I just get people to pull your phone out and just for fun. And what you're doing is you're training an artificial intelligence engine right in the moment to be able to interpret finger doodlings on your screen phone to inform this artificial intelligence engine. We're doing it all the time. We just don't, big businesses have this stuff working in the background, and we just don't see it or have much appreciation for it because it's largely a background activity for big business. We don't get to front up against it too often.
What a wild and promising technology. Now, in the graph in your book, you have AI tied for first, actually, with cloud computing for largest impacts on the industry, but the only reason it lags comparatively, the other axis, it's not nearly as mature. So how long has AI been in the oil and gas industry, and what utilizations have people made with it?
I couldn't forecast how far or how long it's been in the industry, but a very long time for sure. Artificial intelligence came around literally the instant we humans developed computers. The question was very quickly asked because people could see the pathway forward. At what point would a machine be able to impersonate a human sufficiently that you would not know you're dealing with a non-human, like a machine? So that dates back to the 1950s. So it's been around for a very, very long time. In oil and gas, I'm sure there are lots of examples I'm unfamiliar with, but everything from weather forecasting, for instance, uses artificial intelligence. In the use case I've described in my book, which is a earliest one, which I would say has been published and studied, involves a petroleum company in Australia who fed all of their historic engineering content into an artificial intelligence engine so that the engineers could ask in English for a document that they were looking for, using all of the sketchy terms we humans use when we're trying to describe something we can't quite characterize. And the AI engine sorts through these millions and millions and millions of pages of documents and finds the document that the engineer is looking for. And the question they're asking, the way they search for it isn't Google, where you're typing in a bunch of search terms and hoping Google can find it. You're talking to the machine in English, and the machine is listening, interpreting, and then searching for the content that you're after. It's pretty impressive when you see it in action, actually.
And then I have to say, I'm a little curious to hear how independent this technology is, because it's cool to think that I can just speak to it and it can parse through some language libraries and figure it out. Yeah. But does it have the capability right now to execute everything by itself, or does it kind of need some human peeking over its shoulder to make sure it's doing everything correctly?
Well, there are many illustrations of these technologies where it's sufficiently advanced. There's no real requirement for a human looking over its shoulder. And a really good example of this is aerial drone technology for flying a drone. Aircraft today, we humans are innately uncomfortable getting into an unmanned transportation vehicle of any kind. It doesn't matter whether it's a boat or a car or a helicopter or an airplane. It doesn't matter. But the reality is that these engines are now sufficiently sophisticated that the idea of a pilot is largely superfluous. We don't need pilots in aircraft. The engines are sufficiently smart that they can actually take off and land and pilot the aircraft in virtually any condition. Military technology is taking care of that, but we're uncomfortable with it. And this also helps explain the slow pace of adoption of things like automated cars and automated trucks. But there are those technologies are advancing very, very quickly. And the day won't be too far off where there are unmanned trucks hauling goods around on our highways, because the technology is available to do so. It's cheaper, faster, safer, more fuel efficient. And but for things like aircraft, I think it'll be a very long time before people get really comfortable with, I'm going to take a flight from New York to Los Angeles and there's no pilot in the plane. we will really struggle with that for a while.
Yeah, that will. I mean, it's a matter of time with the trucks, of course, but I know so many people who would never be comfortable with flying an unmanned aircraft. But
yeah, or more likely for most of us, because even if flights are, if you look at the whole human population, it's a tiny portion of us actually get on airplanes. We do it a lot, but not that many of us. Many more of us, though, get on cars and buses and trains. And those are all very amenable to human systems that operate without humans at the switch.
Oh, easily. And then the tech industry, I mean, they seem to have no shortage of buzzwords. Even when I was in my data analytics courses or other computational classes, a lot of stuff gets thrown around, a lot of jargon that I think I'm pretty familiar with. But one that did get tossed around was the word digital twin. Does that have any ties to AI? And if so, what is it?
Well, a digital twin is a virtual representation of a physical thing. In an industrial sense, when we build an asset, say a gas plant or a well, we as we're constructing it, we do the design work and the construction, the build, and then we put it into operation. That whole process, we generate and accumulate an enormous amount of data about that physical asset. Everything from who made it and where is it physically located? What's it's made of? What is its energy consumption? What's its performance envelope? How fast can it run? How slow can it run? How do we turn it on? How do we turn it off? All of this data is collected during the construction and delivery of that physical asset. What we have done historically is we've kept all of that data in these different silos. So there's the maintenance engineer has their view of that asset for maintenance purposes. They know its run cycles and when's it scheduled for repair and what are the spare parts that it requires. If you're the financier who's financed the asset, you're concerned about margins and costs of production and return on your capital employed and the volume of product that you're pushing through that asset. If you're the capital arm of your company and you've built the asset, you're concerned about the capital cost and how long it took you to construct it, the schedule. So all of these different asset groups exist in their own little silos. What a digital twin does is it brings them together into a single composite model. And then once you've got it in as a model, you can then start to play with it. You can say, okay, well, I know how it's been built and I know how it's supposed to run. I understand its economics. It's now in one model. Let me vary the inputs. Let me pretend the asset's running in the cloud, like as a physical asset, although it's strictly virtual. Let me vary up the customer inputs, the amounts of oil products that say are flowing through this plant, this refinery. Let me vary the demand profile of who wants to purchase product coming out. Now, let me run that as a virtual edition of this physical asset, millions and millions and millions of times in the cloud. And then from there, I can truly understand the performance and characteristics of that asset under any known operating condition. That's the concept behind a digital twin, is that you can really deeply understand these assets. And there's some really great examples of people who have discovered some phenomenal things. For instance, do you erect one really large windmill that has super long blades, but doesn't run too well when the wind is super strong? Or do you have a smaller windmill, doesn't generate as much electricity, much lower capital cost, but can work when the wind is really, really strong? How do you make that trade-off unless you can take the wind envelope, how much wind is coming at you, and study that at the hourly level so that you can know precisely when your big windmill is going to have to stop running because it can't process the wind that's coming at it? And that's a very, very complex question. And right now we use really gross, lumpy averages to kind of draw that conclusion. Whereas, with a digital twin, we can make very, very precise calculations.
Digital twins definitely hold a world of difference in the terms of maximization and optimization, so I'm excited to see where that goes. But what about big data analysis and interpretation? Sure, it can give us a bunch of data and sort of give us the best idea, but are there trends that AI can discover that just would not have been obvious to human eyes, human intelligence, because they don't have predispositions and biases?
Oh, absolutely. As an example, there is a company in Australia that has developed a natural language processing engine specifically for safety incident data associated with mines. Now, this is kind of a niche area, but you can see what happens. There's an incident at the mine. The supervisor narrates into their phone, Joey was at the wheel of the mine truck, and at the intersection of this mine road and this mine road, the stop sign was not observed, and the truck barreled through the intersection, creating an unsafe condition. No incidents were reported, and Joey was spoken to. There's a block of text. And imagine if you had a natural language processing engine that could read that block of text, put that into a model of your mine operations, and then predict when your next incident is going to happen. That's what this company does in Australia. And that's a very, very clever use of the technology to do things like expand human understanding and apply this technology to concepts that, right now we can't really even begin to fathom how they could be used by a machine.
It's already blowing my mind, using technology to predict the future to mitigate problems that have not even happened yet. That's insane. Yeah. And then you mentioned that AI holds massive potential to enhance, oil and gas exploration sector for sure, in terms of increasing reserves, capital efficiencies. But how do humans help? What needs to happen in order to organize these data lakes into usable formats for these AI machines? Can I just give it a million Excel spreadsheets and a couple other documents and expect it to learn? Or is there a little bit more facilitation necessary?
It's not quite as simple as giving these machines the piles of data and say, here, have at it. It does take some skill sets in areas like data science to be able to structure the data in a fashion that the machines can take best advantage of them. So it's not for a blind application and blind use. It does require some some smarts and some human skill set to do the design.
And then in terms of the smarts required, I remember in high school, way back when, I talk as if I'm pretty old. I remember a couple years ago in high school when there was an AI web browser bot announced. It was called Cleverbot, and you could speak to it, you could type to it, and it would talk back to you. And when it first came out, it was fun. We would ask it questions, prompt it to do things, and you'd have these weird conversations. But in a few weeks, the website was terrible. It was rot data. People, other stupid high schoolers like myself, were going, oh, how far can I push this? So I got on one day to try and talk to it, and it immediately started questioning me about things because that's how it knew to start conversations, and then used the information I gave it to craft some pretty nasty insults. So maybe not as offensive in the perspective of oil and gas technology, but is it relatively important to filter out that rot information? Of course, it's not going to be just mean things, but what does oil and gas need to prevent feeding AI before, I don't know, something bad happens? It develops garbage in and garbage out.
Yeah, so ROT, of course, is an acronym, and it stands for redundant, obsolete, and trivial. And so a good precondition to success with an artificial intelligence application is to remove all of this ROT data from your scenario. And so that it doesn't influence the calculations of the artificial intelligence engine as it's processing. The use case you're referring to is a good one. It's where since these natural language interpretation engines can't tell whether they're being racist or offensive. I mean, these are emotional reactions people have to things. It's an example of where it's not fully intelligent because it's not applying an emotional engine to things and then ends up insulting you. So if you carry that into the industrial world, the issue you have is incorrect data coming into the AI engine. The engine processes it, thinks it's and uses that data to create an outcome which is undesirable. And so some care has to be taken to make sure that that's not the case. But for the most part, imagine you had a use case where you want a machine to interpret land contracts, and so you feed it land contracts and have the machine process the land contract language to interpret the contracts for you and find insights. It's unlikely you're going to find racist input coming in through your land contracts. So it's not a concern that typically shows up as a worry in industrial setting. But certainly if you had land contracts which were known to be in violation of the law, feeding those in and then having the machine try and interpret them and present them as if they are legally binding would probably be a problem. So that's why you have to be mindful of what information you do feed the engines.
And then are there people or just anyone individually developing, I guess, emotional libraries with a high enough resolution that they can mimic human emotion? Or do we want to mostly eliminate that from these professional settings, these business and extraction and mining settings?
Well, I think it would be impossible to say to the world's artificial intelligence developers that AI should not be applied to the task of interpreting human emotion. That's just it's a nice ideal, but I can't imagine any situation where we would be completely uniform as a species and block that development. We have to assume somewhere in the world people are trying to develop AI engines that can not only listen to what we say and provide an appropriate response based on what the engine believes is correct, based on the data that has been fed. And it's doing that trying to understand and read human emotional reaction to what it's just done. Because our emotional reactions, we telegraph things, right? Our face muscles are very, very complicated. Raised eyebrow can signal many different things depending on how you frame it. And so the engines, we have to assume the developers are working very hard to do things like try and interpret and read human emotions in response to what these machines are producing.
And then is it reasonable to just jump in and start taking advantage? I mean, of course, you don't want to implement it immediately, but to sort of experiment with the applications before putting it into the industry? Or should you have a clear goal in mind before you try to get started on this journey at all?
Well, most oil and gas industrialists are extremely practical people. And the idea that there would be some sort of sciencey project that it doesn't have a clear profit-driven outcome, and that's going to get funded is pretty low. That maybe in an R&D lab in some large organization you might find that, but for the normal oil and gas company out there or service company out there, these problems, this technology should be applied to try to solve specific problems which are amenable to that type of technology. And if you're not applying the technology with that profit motive in mind, you're probably not going to be successful in demonstrating much of anything with the technology. So I would counsel companies at this stage, take careful aim at a specific business problem and use the technology to solve the problem. That's the fastest way to success and uptake.
And then when implementing this stuff, let's say we do all of that successfully, is there a problem when comparing human goals with the goals of the AI? I mean, goals used loosely. Are there priorities like human safety that would not be obvious to us to even teach it that might pose threats in the future?
Well, many AI engines will be driven to try to optimize to a specific goal or objective that has been given to the engine. So if the goal or the objective is to improve safety, the AI engines will be able to provide guidance or interpretation of the data they're presented so that safety is absolutely maximized. If you said to the engine, though, I need you to maximize profit, but I don't want you to create any safety incidents, then the machine might interpret the data differently to achieve safety outcomes that you're after and achieve the profit outcome that you're after. So it's all a question of how do you get the AI engine to react to the goals or the objectives that you've set for it, and then let it run and let it execute. And so there's no clear answer to this. And so many AI engines, you actually can provide it with, you can say to it, okay, optimize for margin, optimize for capital cost, optimize for deliverability or rateability, optimize for profits, optimize for safety, lower my OpEx, give me the lowest possible carbon emission solution to this set of inputs, and the engine will churn away and give you an answer. And so safety might be one of the criteria, but I wouldn't always assume, unless the developers have been very clear about this, that safety is always going to be respected. Sometimes these engines, they're like anything else; they will, work with the parameters they've been given, and sometimes safety might not be the parameter they've been fed.
And then I feel like at this point, as a culture, at least here in the West, we've waded through the sci-fi and finally discovered that, well, it's not always out to kill us. Very rarely is AI out to kill us. But today, is there still any pushback for the use of AI? If so, what can we do to convince people involved to trust the AI in their decision-making processes? Like landman going through contracts, geologists through seismic data, engineers doing trend analysis on their own. Will everyone be happy with the work of AI as soon as it is implemented, or are there still some people who don't want to see it?
I think we need to assume that, as in any area of development, it will take time to accumulate the requisite data so that the AI engines can work correctly. And in many fields of endeavor, we're still at the very, very early stages of that journey that we need to be on. And throughout the journey, there will be, as there always are, there will be a whole series of people who deny that this has any merit. It can't possibly replace a human. The work that I'm doing is more art than science. It can't be delivered by a machine. People throughout human history have made that statement over and over and over again, and we've invariably been proven wrong in the long run. So we need to assume that when we are rolling this technology out, there will be individuals who harbor a concern about the impact the technology will have, and will dismiss it, denigrate it, deny it, and the like. That means that the role for management in an industrial setting is to set the groundwork so that these technologies, when they arrive, can be treated with the appropriate level of respect that they deserve, and at the same time, the workers whose jobs are going to be impacted are looked after. And frequently, that's often not the case. That technology is brought in, and the concerns of the workers are left unaddressed. And of course, that creates the change adoption challenges.
And then in the future, let's say somehow, historically it's never happened, but we move past the resentment of technology replacing us. And then we have AI systems who are able to take control on their own, expand their networks, and then we connect them globally across borders. Is this a utopia that we want, or is this way too vulnerable and a security concern for everybody at that point with a worldwide network?
If you're thinking about the China's Great Wall, Great Firewall, if you like, that has been put into place, you're talking about the opposite. How do I create a porous structure? Well, I would argue that that porosity you're talking about, cross-border solutions, is already in place. It's just embedded in things like supply chains and industrial delivery systems, power grids, pipeline systems, which are all trans-border, transnational, and all operate in the background, and we don't see them. So you might call it that utopia. We're already there. That's not something that we should fear. It's probably something we should embrace. And it's here. It's not like it's something that won't exist down the road. It's already here.
Yeah, that's exciting. I'd love to see how that develops. And also, I'd like to go on to the ideas. Of course, we do this show for the people. So I'm a student, I'm a young professional, I'm an older professional, and I would like to get involved with AI. Should I retrain myself to be better tooled to understand this? Should I work for a company in oil and gas? Should I go straight to a data science company? Should it be outsourced? Should I work to be able to implement it from within? How do people get started?
Yeah, and of course this is and the answer to this question is changing constantly. For example, if you went back just 3 or 4 years, to work in artificial intelligence required a university level training in that domain so that you understood the tools and how to use them. But one of the waves of change happening in the world of digital is the democratization of these technologies, and by that I mean the technologies are turning into things that every ordinary person can use. If you think about 3D printing as a concept, if you go back 4 or 5 years, if you wanted to experiment with 3D printing, you were in a university lab somewhere, or you were in the back office of some large corporation. Today, any high school kid can buy a 3D printer for just a few $100s. We watched them all whip into action making face shields during the pandemic. So this technology gets democratized, and the democratization of artificial intelligence is, if you imagine the complexity associated with building things like a digital twin, imagine an easy to use interface as simple as Uber or Google that allows an ordinary person to structure the data that they wish to work with and have an artificial intelligence engine down below doing all of the heavy lifting, and you're insulated from that. That's a world that's fast approaching. And so for someone who is in industry today, who is thinking, maybe my career is, I need to shift it into AI. What you might want to think about is, how do I begin to work with these democratized tools so that I can bring artificial intelligence capabilities into my world? I wouldn't quit a job and then go off and study artificial intelligence. That's not the likely outcome that I see. I see the outcome as if you're a worker in finance, you're going to get an inexpensive, easy to use, democratized set of tools to apply artificial intelligence to the world of finance. That's where you might want to go and become learn how to use those tools.
So don't quit your day job. It'll probably come to you as long as you're willing to learn it, huh? And then that idea is nice, especially if management tried to introduce it. But let's say I'm a tech officer. I want to introduce the idea of utilizing AI. Can I justify the cost right now? Are a lot of people not too keen on spending the money? Or are these expenses dwarfed these days by the solutions that it can't afford a company?
Well, as with everything that is digital, it's riding on Moore's law, which means that for every unit passage of time, 18 months, the cost of AI is falling by 50%, and it's getting twice as capable. So at some point, the cost of working with AI to solve some problems is no longer the question you should ask, because the cost of the technology is so low. The real question is, how can you afford not to? And so I would say to oil and gas companies, if you're not looking at this technology in some area of your business today, you're absolutely going to be left behind.
And then how messy does the implementation transition get? I imagine some of the biggest hurdles would probably be magnitude, agility to adopt that change changing management to maybe better understand this from both an upper level and a personnel side? What are the most difficult parts?
Well, it's a really good question, actually, because I don't think there's a neat and tidy answer that applies to everyone in every situation. Certainly, depending on what a company tries to or takes aim at as it characterizes as its big problem, we'll undoubtedly discover things it hadn't anticipated that are not AI related, but more, say, data related. The data is rubbish. So if I feed rubbish data into the AI engine, I get a rubbish answer. So that just surfaces, I've got a big data problem I have to actually really deal with. That's a frequent challenge that I see with organizations. A second is inability to identify where the pain is the greatest and where AI would actually make a difference. And that varies by company and context and situation. And then third, of course, the problem that all organizations will wrestle with is the adoption of that change, the introduction of this technology. Change management is a constant challenge in this industry.
And then how can management, from their perspective, support the change? Because I know, like you said, historically, there are always people who almost resent this technology because they're afraid it will replace them. How do you prevent people from feeling like my boss walks in and goes, Tavis, this will save you 4 hours a day, and it does something that I could already do at some exorbitant cost, or I don't know, I try to be angry.
Yeah.
How can we destroy that us versus them, that man versus machine illusion that exists within companies?
And that's very much the mission of management, is to be able to explain to the workforce in clear terms why the technology is going to be used, what outcome it's going to serve, and what's in it for the employee. And frequently this is a secondary or if not tertiary comment from management. And so my argument to management is this: if you're not clearly setting the groundwork and clearly explaining to your workforce why you're doing this, then you should expect a lot of confusion and resistance and slow uptake and excuses and backsliding and so on. It's not that should come as absolutely no surprise. Mm-hmm. So this is much less about the technology, and it's as much more about how you communicate it to the workforce and create the conditions for the change to take place.
So you really have to frame it more as a tool than just simply competition that's replacing their hard work.
Oh, completely. If you start out employees are very tuned to this, right? If your change message to your employees is this is going to allow us to do more with less, that's just code for one of you is going to be fired, right? We don't know which one, but if we're able to do more with less, there's a couple ways to think about that. One is there is no more to be done. So if I haven't added more on, somebody somewhere, because I don't have the need for extra people, somebody somewhere is going to go. So that's a problem message. Like how does that resonate? Mm-hmm. So in the same way, if your agenda is I'm going to do more with less, you also need to say, and here's what more I'm going to do, so that the employees who are saying, okay, well, that's a really attractive proposition. I'm quite keen to do that. You're going to grow the company or add new products, embrace new markets. I can get behind that. I can see future for myself, an opportunity. I can embrace this. But a simple more for less where you don't articulate the more, the employees all figure this out super quick. One of us is going to have to go.
And then what is the best way to standardize the data implementation once everyone's on board with going with it? I mean, right now you go to any repository data lake, you've got 50 years of scanned documents. You've got boxes in the back that are unscanned and handwritten. You've got millions of Excel spreadsheets, other PDFs. How do we centralize it and normalize it so that we can push it into an AI system so it can parse, or does it not really need that much help anymore?
Well, it's a couple of things. One is I don't think boiling the ocean is really the answer here, where you have all of this data in all these different formats, and therefore you embark on this monster project to load it all into some environment. I don't think that's how industry will embrace this. It's not very practical. A much more practical answer is you identify the problem where you believe better quality interpretation of existing data can yield a better outcome, and you move that data into a position where you can start to process it, a data lake or a data repository set or what have you. I think that's where this goes as a kind of a first step.
All right.
Now, the second turn to that, though, is even if you've identified this is the problem area I think I can solve, and this is the data sets that I think contribute to this, there is another concept, which is, well, why don't you apply artificial intelligence tools to the raw data so that you can identify which ones are outliers and which ones make no sense and which ones are clearly errors. So use AI tools to actually clean up your data, to feed your AI engine, to interpret the data correctly. That might be a solution to explore, rather than taking your senior engineers, who are the only ones who really understand the data, and pulling them off engineering jobs, which they love, and putting them onto working with cleaning up data, which is dull and they hate.
Yeah.
You use AI engines to solve that problem for you.
So definitely specialized solutions over just a magnitude of, hey, find some patterns, machine. And then
Exactly.
this technology seems like a game changer, and it's like we've mentioned a few times, it is only a matter of time before it's a standard, really. So
Exactly.
how can our excellent audience members, I'm going to go through a few different tiers, how can they learn to better prepare themselves? So C-level people, what can they do to understand and implement AI?
Well, at the at that excuse me, at that executive level, this is unlikely that audience would ever find themselves, hands-on with these kinds of technologies. So the real requirement at that level is to learn the range of the capability set that this technology represents, so they can start to situate it into context. And then to use their insights from the domain that they happen to be specialists in. If you're an oil industry executive, you worked in the industry for 30, 40 years, now you're presented with this novel technology, that your job is to forecast how you think this might change the industry, your company, and then figure out strategically how do you change, alter your roadmap, your agenda, so that you're taking full advantage and not sideswiped by this.
Mm-hmm.
That's the role at the C-suite level.
All right. And then I imagine management is probably the conduit to communicate that embrace change down to technical and field personnel. And what else do they have to do?
Well, their main job is the communications aspect of it. But for managers, who are tasked with the day-to-day delivery of results and execution, and they're certainly one of their tasks will be to identify where this technology is going to have the greatest impact, mobilize the people and the resources and the money and the time to go and go after this, align this initiative up with all of their other initiatives that they've got underway, so that it fits and it can be explained and makes sense, and then to supervise its execution to make sure that the results actually show up. Like a big problem with many of these technologies is that the team that builds them and for business is often not the team that's going to use them. So management is like the communications engine that bridges the gap between the delivery side of this change and the end user side. Mm-hmm. That's a key role for them, is to make sure that alignment stays intact.
And then I'm almost afraid to ask about the technical and field personnel, because I imagine senior engineers, they will be given the tools, they will learn how to use them, and they will be using them. But let's say me, young guy in the company, do I have to look over my shoulder to make sure I'm not going to get chopped? Because like you said, more with less is a good way to phrase it, but it is a fact of the matter that AI is going to replace a bunch of human capability.
Yeah. I think for the frontline worker, if you are, or if you discover that there is the potential for this kind of technology to come into your world, and you've got some choices to make, and one of those choices is I'm going to be part of the solution here, and I'm going to help figure out how this works, and I'm going to do my job to train the machine and play that role. That's one choice that you could make. Another choice you could make is over my dead body. Not coming into my range.
Uh-huh.
Another option is, if you're senior, very senior person, you're close to retirement, is I'll just delay this. I don't want to deal with this. I just want to get through this and get through to my maximum pension position. So people, depending on their situation, they got choices to make. And there isn't a nice, neat, and tidy answer here. My advice to people, though, is that the pace that these technologies develop and the competitive world that we live in suggests that the most likely and successful course of action is to figure out how do you embrace this and help it work in your world. And that's a stance that is very hard to take if you do not sense that management has your back and they're going to support you. You got your get out of jail card when things go sideways. If you don't have that, that's a very hard position to take.
And with all the emotion you've described, I almost wish AI would take off and just replace everybody because, like you said, a lot of pushback, a lot of resentment, a lot of delay if you're close to retirement. It makes you wonder how much we're limiting ourselves. But something else limiting ourselves, I think the time for this episode, it's drawn out, it's come to a close. I believe we've talked about everything. So again, thank you, Geoffrey. And for those of you out here listening, great information on this podcast, right? Well, it's not going to be as good as what you can find in this book. $10. That is cheaper than probably your breakfast if you were to go out to a restaurant. I don't know where you live, but at least here it is. And this is going to be supplementary knowledge that will stay with you forever. So, Geoffrey, thank you again. Is there anything else you would like to say?
I certainly hope that if people are interested in this topic, they'll purchase the book and give it a read. It's also available on audio format on Audible. So if you want to listen to it on, then that's another way to consume it. And then last but not least, I've converted the book into a one-day series of little lectures, which is available on Udemy. And if people were interested in taking getting the insights of the book, but delivered in a presentation format, then Udemy might be a third way to get the same concepts.
You hear that, everybody? You have plenty of avenues to pursue this, and it sounds like you're running out of excuses to not have taken advantage of this information. So, like you said, take the course, pick up the book, listen to the book, whatever. Just stay with the times. Don't get left behind because this is the new industry. So thank you again for joining us. Thank you, Geoffrey, for joining us on the show as well. And until we see you next time, everybody, take care.
Bye for now.